Hello everyone. So today we are going to be solving a integral using partial fraction decomposition with matrices. So getting started with this problem, this is our example problem right here. Okay, so what we're going to want to do, so we need to recognize that we need to use partial fractions. So what we're going to do is we're going to have to solve for A, B, and C, okay? So we got this right here. What we're going to want to do, so since we have an irreducible quadratic right here, we're going to have to write ax plus b all over x squared plus 1 all over, and then so it's c for x plus 2, like that, okay? And now what we're going to want to do, we're going to want to cross multiply. So this times this, this times this. Okay, so I'll write that down real quick and I'll be right back. Okay, so I wrote this down. Now what we're going to want to do, we're going to want to cross out x squared plus 1, that x plus 2, x plus 2. All right, and now let's rewrite this. All right, we got this. So now what do we do from here? So what we're going to want to do, we're going to want to expand this and then group them by their like coefficients, their similar coefficients. So I'll expand this real quick. Okay, so I expanded this to this. And now what we're going to want to do, we are going to want to group the terms by their like coefficients. So see this right here, ax squared and cx squared. They both have a like coefficient of x squared. So what we're going to want to do, we're going to want to write x squared a plus c. All right, so that would be our first one. Our next one would be x, okay? So we have 2ax and bx. So what we're going to want to do, we want to write x, 2a plus b, like that. And then now for our just regular integers, we're going to have 2b, and c, all right, plus 2b plus c. Okay, so now we have our like coefficients here. And what we're going to want to do is make a system of equations from this, okay? Okay, and we make these system of equations by setting these equal to each other. So this x squared right here, right, it's attached to a plus c. And this x squared here, call it 1, okay? Because there's nothing in front, so it would just be 1. So it'd be a plus c equals 1. A plus c equals 1. That would be our first equation, all right? Our second equation, this, our x variable right here, is attached to 2a plus b. But we see that there's no x right here. So we're going to want to set it equal to 0. All right, and then this, our regular integers here, 2b plus c, we're going to make that equal to 3 because this is just a regular integer here. And we're relating the like coefficients. Okay, so now these are our 3 equations that we're going to use, and we are now going to make our matrix. It's going to be 1, 0, 1, 1, 2, 1, 0, 0, 0, 2, 1, 3. And when we have this matrix right here, we're going to want to use Gauss-Jordan elimination. And it's Gauss-Jordan elimination. It's not that hard. You just do some row reduction and then get the RREF. So when solving this matrix for RREF form, First, what you're going to want to do, we're going to want to do negative 2 times row 1 plus row 2 to row 2. This will give us the matrix 0, 1, 1, 0, 1, negative 2, 2, 1. This will give us this matrix right here. I'm going to keep the line out for now because there's no room over there. But after that, let's just put the arrow down here. We're going to want to do negative 2 times row 2 plus row 3 to row 3. Then we would get 1, 0, 1, 1, 0, 1, negative 2, negative 2, 0, 0, 5, 7. We'd get that. Then after, now we need to use some fractions to get rid of these two integers right there. So what we're going to want to do, 2/5 times row 3 plus row 2 to row 2. This gives us that, and then now to get rid of this one up here, we're going to want to do negative 1/5 times row 3, row 1, row 1. Now this will leave us with 1, 0, 0, 2, 0, negative 2/5, 0, 1, 0, 4, 5, 0, 0, 5, 7. All right, and then now what we want to do, we want to make this 5 into a 1, so 1/5 times row 3. So this is our final matrix in reduced row echelon form. And these are our A, B, and C's. So this corresponds to A, B, and C. Okay, so now that we have our A, B, and C values, all we need to do is just plug them into our equation right here. So now we're going to do the integral of A, which is negative 2/5 x plus 4/5 all over x squared plus 1 plus c, which is 7/5 all over x plus 2 dx. All right, and let's split this up into two different integrals to make things easier. Okay, so now that we have these two integrals split up, what we want to notice is that this integral can be split up even further into negative 2/5 x all over x squared plus 1 plus 4/5 all over x squared plus 1 dx plus 7/5 all over x plus 2 dx, like that. All right, and now what we want to do is we're going to pull out the constant here, okay? Also, we're going to make this into another integral. pull out the constant, 1 over. Pull out the constant for this one. Like that. So now for this first integral right here, we're gonna have to use u substitution. Okay, we're gonna make our u equal to x squared plus 1, our du equal to 2x dx. And for this, we need to get rid of this 2 to get just x dx. So we're gonna make this half du equals x dx, just like that. And now we can just pull this half outside, so it's going to be negative 2 over 10 integral 1 over u du plus 4/5 1 over x squared plus 1 dx. Like that. Now we can integrate. So for this, like we would also use u substitution here, but we can do that in our heads. So now solving these integrals, integrating them, this first term is going to be negative 2 over 10, the natural log, and u would be x squared plus 1, squared plus 1 plus 4/5. Now for this one, we would not use u substitution, right? We know the derivative of arctan or tangent inverse is this. So this would be 4/5 arctan x plus 7/5. Now this one we would use u substitution, but we can do that in our head. So it would just be 7/5 the natural log of x plus 2 plus c. And this right here would be our answer. All right, guys, thank you very much for watching. See you next time.